IAP 5 brings better error handling and initialization, streamlined product fetching, new features like webshops are on the way, and we've integrated IAP 5 with payment providers like Stripe and Coda, since you now have more options beyond the traditional native stores. This means better targeted sales to fit players and their interests, purchases are made more directly to you or your studio, and you can keep a greater share of the purchase revenue. So like me, you probably have some updating to do, and in this video, we can walk through it together. If you're new to working with IAP, you'll be able to easily follow along with this video because this is basically an introduction to IAP 5 after we look at some differences in initialization with the previous version. We have a documentation page on updating, and an advantage to the video format here is that we can look at the changes side by side with IAP 4 on the left and IAP 5 on the right. We also have a discussion article to accompany this video at the link in the description. If you want to come back to this video later, the chapter is mapped to the code regions which follow the flow of store initialization and connection, event handling, defining products and product and purchase fetching, and the purchase flow. I know that sounds like a lot, but each piece here is straightforward and everything closely follows the IAP 5 package samples. Alright, so I'm going to start with updating the IAP 5 package. And as expected, we have some errors, though not the ones I was expecting. The console errors are related to store-specific product IDs. The type IDs was renamed to store-specific IDs. I'm doing the rename manually since the quick fix in Visual Studio doesn't offer a rename. Okay, that's a small fix. Let's talk through the bigger changes, starting with an overview. If you want to familiarize yourself with IAP 5 before diving into your own code, the IAP samples are worth looking at. I'd start with the minimally coded version, and Paywall Manager is the relevant script. My script is called Store Client. In GemHunter UGS, we use the client suffix for classes that call Cloud Code functions, which makes the codebase easier to navigate. We're not covering Cloud Code in this video, we just have a call to validate and grant purchases securely on the server side, similar to what you'd have in place with your own backend. Let's talk through IAP 4 a little, because sometimes when you get around to updating things, you have to remind yourself how things worked before. The version 5 update is a shift from interfaces to events. IAP 4 required you to implement the iStoreListener or iDetailedStoreListener for store initialization and purchase processing, and used StoreController to initiate and confirm purchases. In IAP 5, those interfaces are gone, replaced by StoreController, a concrete class you retrieve yourself with events you subscribe to for store connection, products, and purchases. In a nutshell, StoreController is your handle for everything store-related. But first, we need to get it, so let's start at the beginning with initialization. In start, after getting some dependencies, I call initializeStore. This is the same in both versions, though note that I have a define for initializing the store with a payment provider if you want to offer purchases outside of Google Play or the App Store, using a payment provider like Coda or Stripe. Payment providers are a new feature we'll talk about soon in a future video. Let's go to initializeStore. In version 4, we initialize the store by calling Unity Purchasing.initialize. We sent in the iDetailedStoreListener, which this class derives from, and a configuration builder containing our products, added via code like I have here or loaded from the IAP catalog asset. In GemHunter, we define products manually in code to keep things explicit. That way you can see exactly what products exist without opening a separate asset. After calling Unity Purchasing.initialize, we'd wait. And then the store system called back using iDetailedStoreListeners on initialized, and we received an implementation of iStoreController, our handle for starting purchases, confirming purchases, and refreshing products mid-session. In version 5, we retrieved StoreController ourselves by calling Unity IAP Services.StoreController. Before we use any of the services, we need to initialize Unity services first with Unity Services.initializeAsync. In the GemHunter UGS project, we handle Unity service initialization at the start of the game in a script called Game Initializer. And if you want to explore GemHunter UGS as a reference project, that script is a great starting point. After we have the store controller, we subscribe to IAP events. That way we don't miss anything the store fires during or after connection. After subscribing, we call connect to connect IAP to our current app store, Google Play or Apple. Behind the scenes, what happens here depends on the store, but overall connect registers our intent to use store functionality. Let's take a look at the events on StoreController. We have events for store connection, purchases and products, and the purchase lifecycle. Everything is handled by the StoreController rather than it being split between the iDetail Store Listener and iStoreController in version 4. While we're here, let's look at the on-store connected and on-store disconnected handlers. This is where I now handle subscription to UI events fired from purchase buttons, and I have a to-do note here that we should disable the UI buttons when the store is disconnected, which we do by implementing a connection state event. Back in Initialize Store, now that we're connected, we send our product definitions to the store to request their current details. You can think of it like calling Google Play or the App Store with a list of products and saying, "Tell me what these cost and what they're called in the player's language." And the store responds with localized pricing and descriptions for the current player. In Gem Hunter, we define products manually, but here I also have an implementation of IAP5 and the IAP catalog, so we can look at both. If use IAP catalog is true, we load products from the IAP catalog asset set up in the editor. If it's false, we build them manually in the code. In IAP5, we don't use IAP4's configuration builder anymore. That was a setup package you had to assemble upfront before initialization could begin. In IAP5, you pass product definition objects directly to fetch products whenever you're ready, each one specifying a product ID and type. So there's less platform-specific code to write compared to IAP4. Now we just call StoreController fetch products and send in our product list. In build product definitions from IAP catalog, we load the list from the IAP catalog asset. And notice we use item type here rather than hard-coding consumable, so the catalog drives the product type. In build product definitions manually, we build our product list directly. Each product just needs a unique ID and a type, consumable in our case. StoreController then fires the onProductFetched callback with a fetched product list, which we'll log for the demo. Now that the store is connected and the products are fetched, it's the right time to fetch purchases with StoreController fetch purchases. This can be used for checking any entitlements the player has, and it also surfaces any pending orders from interrupted sessions. OnPurchases gives you a full orders object, and I'm just logging pending orders here as an example. If you have non-consumables or subscriptions, confirmed orders from fetch purchases can generally be treated as valid entitlements. Check entitlement is available for additional verification, but isn't typically necessary. An important note, fetch purchases will invoke onPurchasePending for any pending purchases that haven't been handled yet in the current session. Interrupted purchases get another chance to complete. However, on a few minor versions of iOS, onPurchasePending doesn't fire correctly for recovered purchases, meaning that unless we handle the pending purchase here, those interrupted purchases will silently slip through with no second chance. To make sure nothing is missed regardless of iOS version, we're calling processPurchaseAsync directly here for any pending orders in the list. Since onPurchasePending does fire correct on most iOS versions, the same order could be processed twice, so we're going to catch any potential duplication in this purchase processing method later, so it's safe to process here even if onPurchasePending also fires. If fetch purchases fails, we log it. Pending orders from interrupted sessions won't be recovered this session, but we'll retry on next launch via fetch purchases. Before we move on to purchasing, we have one final call in Initialize Store to initialize receipt validators if needed. Apple validates receipts within StoreKit 2, so by the time we get the receipt in onPurchasePending, it's already validated. Google Play hands us a receipt that our code is responsible for verifying, so that's what the cross-platform validator is there for. This requires your Google license key to be set up via the obfuscator tool in the IAP package. You'll see this receipt validation in the next section. So let's move on to purchasing. My various purchase UI event handlers largely stay the same. They simply call initiate purchase with a product ID. In initiate purchase, first we have a flag for is purchase in progress. We can use this to disable UI buttons when necessary, which prevents accidental duplicate purchases. We could find the product by searching through all our fetched products, but that's more useful when we need the full list, like for populating store UI. Here we already know which product we want, so get product by ID is the more direct choice. It returns null if no matching product is found. Then we call StoreController purchase product. In version 4, this was called initiate purchase. We send the full product object rather than just the product ID. Purchase product in version 5 takes a product object, which contains the localized metadata the store needs to identify the transaction correctly. It's worth noting that StoreController does have a purchase product overload that takes a string ID directly, but if the product hasn't been fetched yet, it will attempt to purchase it as an unknown type rather than throwing an error. Our approach ensures that we only purchase products we know exist. Now that the purchase is initialized, we have our purchase processing. Process purchase in IAP4 has been replaced by a handler for StoreController's onPurchasePending event, which receives a pending order. This is where you add your validations, grant the purchase or reward the entitlement, and then confirm the purchase, in that order. You want to ensure the player has received what they paid for before you tell the store the transaction is complete. I'm going to handle all that in Process Purchase Async. The main change is that now it takes a pending order rather than a product. But other than that change, things are similar to what I had before. We check that the receipt isn't null or empty, and then we log the receipt for debugging. Next, and this is something I've added based on feedback from the Unity IAP team, we check a process transaction ID's hash set. On most versions of iOS, pending purchases from interrupted sessions are delivered automatically through onPurchasePending on startup, and can also arrive again when fetch purchases runs. Without this check, a player could be granted the same purchase twice in the same session. The hash set is declared up in our fields, and it's just a set of transaction ID strings we've already successfully processed. We add to it in onPurchaseConfirmed. So it only triggers if we've fully completed the purchase flow for this transaction already in the current session. Cloud Code can handle cross-session deduplication via transaction ID, so together these two layers ensure a purchase is never granted twice. Then we do our Google receipt validation, and if this is invalid, we fire a purchase failed event for the UI to respond to. Then we call the Cloud Code function handle purchase. This does server-side validation, for example, checking that the transaction ID isn't a duplicate, and our Cloud Code grants the purchase and returns fresh economy data, the player's current coins and boosters, straight from the server. If you have a small project without a backend, you can grant the purchase client-side here instead. We then use a helper method in the economy manager that relays that fresh economy data to the UI and everything else. And after all that, we call confirm purchase, which tells the store that the transaction is complete. The order of operations matters here, grant first and then confirm after. Finally, we want to reset our purchase in progress flag. The StoreController fires onPurchaseConfirmed when the store acknowledges the transaction is finalized. Here we log the confirmed product from the ordered items and invoke a successfully purchased event to notify the rest of the game, passing along the localized title of the product to display. Note that we add the transaction ID to process transaction IDs here. Remember we had that duplicate check we added earlier in Process Purchase Async. This is where we close that loop. This is the right moment because confirmation means the full purchase flow completed successfully. We also have onPurchaseFailed. Here we check the failure reason from the failed order. If the player cancels the purchase, we handle that differently than a genuine failure like a payment decline or store not connected. Either way, we reset is purchase in progress so the player can try again. And finally, onPurchaseDeferred. This fires when a purchase can't complete immediately, like parental approval via Ask to Buy or strong customer authentication, SCA, which is required in Europe. We reset is purchase in progress here too, since onPurchaseDeferred may be the last event we receive for that purchase. A parent might never approve the request. Since version 5 uses subscribed event handlers, we need to unsubscribe from everything, both our IAP events and our UI event handlers. And there we have it. GemHunter UGS is updated to IAP 5. A significant update with many architectural refinements and new features on the way, like payment providers and web shops. We'll tackle those in a future video, so we'll see you there.